Multiplying and dividing radical expressions. We'll go straight to the examples here. There are a couple properties, but I'm not going to write out the properties. You can figure out what the properties are saying based on the examples. These are three separate examples here. Simplify these three problems. Square root of 2 times square root of 8. There are a couple ways you can do it. You can either multiply, what I did is just multiply the numbers underneath and simplify from there. The other way of doing it, you could simplify each radical and then multiply. So I could have simplified square root of 8 first and then multiplied, but it makes more sense in this one especially just to multiply these two numbers to get 16, because then I know the square root of 16 is 4. Okay. Same thing down here, I just multiplied the two radicals to get negative 125. The cube root of negative 125 is negative 5. Here, no real root because you can't take the even root of a negative number. Okay? So those are three separate examples. Do we have questions on
So for these, we're not going to have to write like something high?
No. No, all we're looking for, just like in last night's, we're looking for the real roots. Okay, so if you have an even root of a negative number, you put no real root. Okay?
Can you hold on for a second?
Yes.
Okay.
Okay, next one. Two separate questions. Simplify. Simplify 72, square root of 72, x cubed. Now we're going to simplify the square root of 72 like we always have. You got to break it down to, you want to pick the largest factor of 72 that's a perfect square, which is 36 and 2, right?
Yeah.
So break up the 72 to 36 times 2. Now when you break up a variable, the variable when you're taking square roots needs, the exponent of the variable needs to be divisible by 2. So since I have x cubed in this case, I'm going to break up the x cubed to x squared x. Right? So basically you just need to take one away if it's an odd exponent. So does everybody understand how I broke up this one? 72, 36 times 2, x cubed, x squared, x. Now I underline in red the perfect squares. The square root of 36 is 6. The square root of x squared is x. What am I left with underneath? 2x. There's your answer. That's it.
Where does the other x go?
Which other x?
The one to the right of it.
What?
The one to the right of x squared.
It's still there.
It's there.
It's right here. The square root of x squared, this x squared came out as x. And you're left with this x underneath. I brought the red ones out.
You have to bring.
Okay.
You have to bring a variable and a number.
No. If you can't bring the variable out, so if I had just x in the beginning, you couldn't bring the variable out.
What? Okay.
Okay? Over here, cube root of 80 into the fifth, broke up is 8 times 10. Broke up the 80 is 8 times 10. Broke up into the fifth is n cubed n squared, because the 5 needed to be divisible by 3. Okay? So I broke it up as n cubed n squared. And then I underlined the perfect cubes. The cube root of 8 is 2. The cube root of n to the third is n. And I was left with 10n squared underneath. Does that make sense?
Why do you leave that 3 right there? Or you just always leave it there?
Right here?
Yes.
Because that's what the original problem was. It was the cube root. So this radical was cube root. It doesn't change
Okay.
throughout the problem. Same thing over here. It started out as square root, ended as square root. Okay. Next. All right, this is just like example 1. You could multiply everything underneath to start with, or you could simplify them separately. I multiplied everything underneath. Since they're both cube roots, you can do that. Okay, if they were different radicals, you could not put them together like I just did. 54 times 5, 270. I left x squared, x cubed. I didn't add the exponents here because when you take the cube root, what must the exponent be divisible by? 3. So it wouldn't make
So-
sense to make that x to the 5th when I'm
You
gonna,
just have to go back.
right, when you're gonna have to go back and break it up as x cubed, x squared. Now when you put these two together, what's y cubed, y to the 4th? Y to the 7th,
Make it Y to
and
the
then you break that up as y to the 6th y. Make sense? Okay? And then I broke up the two, 70 to 27 times 10. Then I underlined the perfect cubes for you. What's the cube root of 27?
3.
3. Cube root of x cubed,
X.
x. Cube root of y to the 6th, y squared. And then I'm left with 10x squared y underneath.